This is my video for drying with anhydrous agents. So what's the technique? Drying agents, also called desiccants, are used in order to remove trace amounts of water from an organic solution. Desiccants are hygroscopic substances that induce or sustain a state of dryness in its vicinity. Drying agents have widespread use in food, pharmaceuticals, packing, and electronics. Desiccants are chemically stable and chemically inert. A more common example of a drying agent is a silica gel pack. So common household items that are found that silica gel packs are found in include cereals and vitamins. I also found cat food on the internet. I don't know if that's true. But the types of drying agents are calcium chloride, sodium sulfate, calcium sulfate, aluminum oxide. And going back to the silica gel packs, these are used to keep things dry and to absorb moisture. That's why they're found in common household and a lot of common household items. And the efficiency of these drying agents varies greatly from one solvent to another. In the case of anhydrous agents, efficiency refers to the amount of water left in the organic solution after the drying process is complete. So how does it work? This is just a picture of a chemically active drying agent, and then the pink is chemically inactive. So chemically active agents have two possible modes of action, chemically active and chemically inactive. Chemically active drying agents form drying agents that bind with water in the form of crystallization and may be generated by heating. Chemically inactive drying agents react with water and cannot be regenerated. So the purpose of drying agents is to remove water from an organic solvent in order to isolate chemical compounds. The drying agent is added to solution and is mixed. Once the solution dries, there should be some drying agent left over. And once the solution is completely dry, vacuum filtration is performed to remove the drying agent. And one thing I forgot to mention on the types of drying agents, calcium chloride is not very reactive with carboxyl amino and carbonyl group, or hydroxyl amino and carbonyl group functional groups. And let's see, going back to here, some chemically inactive some chemically active substances include calcium chloride, sodium sulfate, and magnesium perchlorate. And then the procedure. Step 1, you add a small portion of drying agent to an Erlenmeyer flask. This portion should be about the size of a pea. And step 2, you swirl the flask gently. Then step 3, add additional drying agents until small particles are seen. Step 4, decant or pour the solution into an unused beaker to remove the drying agent from the solution. Step 5, rinse the drying agent with a few portions of fresh solvent. And step 6, combine the rinsings with the dried solution. So going back to step 2, when you are swirling the flask, you should keep in mind that some of the particles are going to stick to the glass and clump into larger particles. And for step 4, you only pour the solution if it contains sodium sulfate, calcium chloride, or calcium sulfate. And if your solution contains magnesium sulfate, then you use gravity filtration to get that drying agent out. And then here is just a graphic of the procedures. So step 1, this is just step 1 where you're just adding that small amount of your drying agent into your beaker. This is step 2 where you just swirl gently, swirling those small particles around into larger particles. This is where I was talking about the chemically active and chemically inactive drying agents. So the wet one will be the chemically inactive, and the dry one will be the chemically active agents. This picture down here is them showing the vacuum filtration of the drying agent. This small picture should be the particles that you get once you've performed your vacuum filtration. These are what your particles should look like. And this last picture is just showing back from step 2 of how those small particles will clump into larger particles into your flask. And these are my references. Thank you.